going through, we were looking at definition of terms, and the main term that you are defining is the object. And today I want us to emphasize much on objects, and maybe to understand why objects are able to communicate together, because we said they have their own characteristics. And one of the characteristics that we talked about is what you call polymorphism, inheritance, and what you call encapsulation. Then we said we still have what you call abstraction. And I think there is an assignment that I gave you that you are supposed to submit, and I have not seen yours. Please, can you send please send that assignment?
Yes, I will.
So it is recorded in your day-to-day activity. So please, it will be recorded in your marks.
Okay.
So I think I have seen for Jerry. Jerry, welcome. I have seen your assignment and I have marked. So what we are saying is that mostly we are dealing up with objects. And the moment we are talking about object, there are 3 characteristics or 4 characteristics that we are supposed to talk about. One of them is encapsulation, inheritance. We have abstraction. And the moment we are talking about those characteristics, they assist the user to design a good model. That's why today's topic, of which I have sent some notes, talks much on principles that we are supposed to observe in coming up with a model. So allow me to use some presentation of a PowerPoint when I'm explaining, and then I'll be able to share some notes to you. Let me try to break what we'll be doing today. And if you look at principles of data modeling, we will look at what is a model. Then after that, we look at characteristics, or we can say maybe importance of this model. Then after that, we will talk about what you call UML and their importance. So those are the things that we need to tackle today, so that now we can proceed with the next topic after that. So when you talk about model, we say that a model is a presentation of reality, or a real presentation of an object. Real presentation of object. So if you remember what we said about the object, it is an instance of a class. It is a real presentation of something. And this is maybe a student, maybe we have a person, maybe who is an employee somewhere, or an employer. And that is why mostly we need to work with these principles. So if you look at my notes that I have shared in your portal, so we are saying a model is defined as a simplification of reality. And when you talk about a simplification of reality, I will be able to talk about maybe a certain object, maybe Vika Superhighway. Vika Superhighway is a model. Vika Superhighway is a model, and this model has its own process. So you have some processes that are undertaking in a Vika Superhighway. So in this case, we can say the moment we are coming up with Vika Superhighway, we were dealing with what you call a project. And when you talk about a project, we are talking about activities that are supposed to be done on this model that we have. So when you combine various activities, and these activities are able to connect together and be able to form what you call a process, or a step-by-step approach, now you design what you call a model. So that's why we are saying a model is a simplification of reality. In this, we are saying representing only those aspects that are required to be understood by a certain people. So how will you understand this is superhighway? You'll understand that it is Vika Superhighway because we have a process. Like now, because we have said it is a project, suppose now you are starting a business, and this business, we can say it is maybe a grocery. Maybe there is a grocery. That is a project. And for this project to meet its objectives, you must correct some presentation of a given process. One, you need to look at finances, financials. So when you look at finances, you must know, where will I get money to fund this project. Then we must look at location, because you cannot sell sukuma wiki, or maybe you cannot sell grocery to where people, they don't prefer maybe buying fruits. So you have to look at now the location where we are looking at. Then we need to look at now the business itself and the building. So where is the building? So you need to look at where we are supposed to allocate the building, because we cannot say that you are locating a building somewhere inside there, where now you need to target people who are passing on that road. So this project requires some processes. That's why we wake up today and you say, I am starting a grocery, but first of all, I will start by coming up with a structure. Then the second thing that I will come up with is maybe to come up with some items that I need to locate on that. So when you talk about a model, we are not only looking at something that is functional in terms of maybe a project that is undertaken by the government. So in this case, we are still looking at various aspects between projects that you come up with. So that's why we are saying the main aim of modeling. Why do you need to model? Why do you need to come up with a presentation of this thing that you need to come up with? So I want a glossary. So I try to draft from the first step until the last one. So when I try to model from the first one to the last one, so that is the case that we can say we have to visualize. So one advantage of a model allows you to visualize. It allows you to view the system in form that can be communicated. Look at an aspect where we have people, maybe the architectures. The architectures, you come up with a structure of a building. And when you come up with a structure of a building, now, whoever now is supposed to come up with that building will now be following the structure that has already been provided for you. So in this case, when I will be looking at the end product, I will be looking at the visualized object. I will be visualizing whatever has been presented by the architecture, then I present by whatever has been presented by who was coming up with that building. So that's why we are saying we visualize. But the moment you are coming up with a structure that will be used by this person who will be coming up with this house, becomes what you call a blueprint. And that is one of the advantages that we will still look at. So that's why we are saying the aim of modeling is to allow visualization or view the system in form that can be communicated to people and the system as it is or required to be. So in this case, the government requires you to have a two-story building. Now you need to present that structure so that that structure can be visualized by the government. And we say it is active. It is okay, that can be used within that environment. Then we are still saying we can provide it as a blueprint or a template. So a blueprint is something that you look after. Like now, you are coming up with your projects, and I think you have started your projects. And the moment you are looking on a project that you are doing, you must come up with a structural way of doing it. You cannot start by creating a system, whereas you have not identified the objectives. You must come up with an objective. Then after objective, maybe you come up with a design. Then after that, you look at the functional requirement for that. Then after that, you model the system. So this blueprint assists the user to come up with, in a simple case, to come up with an efficient system or a true model, to come up with a true model. And in this case, there are various software that you can use. One of the software that you can use is what you call visual software to design a blueprint. If you are using maybe a word application, maybe you want to draw something, you can still use that. But in this modeling systems, we use visual. There is another one that is now in the market, of which it has expired in the market. It is called Stella, but I would not urge you to use Stella, because the moment you are using Stella, it is somehow complicated when you're using it, because it requires some pinpoint over object, real object. Maybe they have to communicate. So you must be able to show how they communicate together. So you must try to design interpretations. But for visual, you only require you to show the processing that has already been done without creating some visualized projects in that. So that's why we are saying it is presented as a blueprint. Then the next one is a structure and a behavior can be specified so that the required system can be built. So when you come up with a structure, we'll be able to look at now that is the real object that you need to come up with. Then when you come up with that real object, you need still to look at the behavior of that. Now, when I'm talking about grocery, who are you targeting? You are targeting maybe middlemen who will be buying those items. Maybe you are targeting the other business ladies or men who are now buying those items, maybe to assist their companies in doing that. So in this case, when you are defining a model, you need to look at the behavioral aspect. It allows you to visualize. It allows you to provide what you call structure and behavior of that project, and it's still to provide what you call a blueprint. Then the last point that you can say to provide documentation. Remember, if now a government comes and tells you what you have built is not implemented in our systems, we can provide that. So you provide to them. So it is provided as a documentation, because a model, when I talk about a model, don't look at something that is not functional. It is something that is functional. And when you talk about something that is functional, it is a real presentation. And I think if you look at the Vika Superhighway or any other maybe project that you might be having on that, you look at Vika Superhighway as a real system, as a real project. But this project utilized money, utilized resources, utilized manpower, and many other things that utilize on that. So you must document them. And that's why we have to look at now documentation. And if you look at a model, we can always say that a model, you cannot wake up today and you say that you have already developed a model. You have to look at now a bit of chunks or structures. So you come up with the first chunk, you come up with the second chunk, you come up with the third chunk, then first and third chunk and second chunk can be able to communicate together. So in this case, when you use a model, or when you are using a model, you now reduce complexity of the system. And let's say now it's a house that you are building. If you wake up today and we say you are building a house, and then you start building. So in some cases, you will always find that now that house that you have already built, it's not even accommodatable. You cannot accommodate everything. But if you come up with a structure, there is a table room that requires maybe 20 feet or 30 feet. So you will be able to come up with a real project that will be presentable in that case. So that's why we are saying a model are built of complex systems, as human cannot comprehend such a system in its entirety. Human beings have a limited ability to understand complexity in its entirety at once. So in this case, you have now to make the users understand the system. And for you to make the users understand the system, that's why I'm saying we use chunks. So small models. So we are using modules, if I can use that one. We are using some modules. And I think because now you have already started programming language, you know what are modules, because modules assist you to come up with the simple structures, assist you to understand the program, assist you to understand how the system is flowing, how it is communicating to each other. So in this case, we can say there is a bit of interpretation of the system where the users will be able to understand whatever you are trying to come up as a system. Now, before we continue from there, maybe to know on how we can be able to reduce that complexity or how to manage the complexity, that's why I've said we need to use some approaches here. We need to understand we need to understand model as a real presentation of day-to-day activities or a project. And when you try to define a project, you always say these are the activities or benchmark of a given project that we are supposed to have. But if you look at what we have said here, we are saying automatically we reduce complexity. We understand the complexity of the system. We understand the system clearly. And how will you do away with this complexity? So that's why we are saying we have approaches that are able to manage this complexity. And when you talk about complexity, is something that is now resulting to some issues of your system. One of them is abstraction. And I think it is not new to you because I think I gave you an assignment on this when you look at abstraction. Abstraction, this is when you are considering some workable systems and non-workable systems, or important system and non-important systems. Meaning, when you're coming up with a project, it is not a must to include everything to users. There are those things that you include to users or you give to users. There are those things that you present to users, in that they require them. But those things that they don't require within a system, there is no need. That's why we do what you call abstraction. So abstraction will reduce this complexity, because if you look at now a system, like now, the moment you are coming up with Vika Super Highly, if somebody brings you a complexity, it was so complex. If you are coming to that place, maybe at that time, you find that maybe the route, maybe the way will not be clear. But now there are those routes that has already been utilized so that we can be able to have less complexity within the system. And then after that, we say, this is a system that was very simple to come up with. So in this case, we need to abstract everything. So there are some things that has already been hidden, which are not even relevant to the users. And these ones, you must look at different models. Remember, we have said we represent the model in layers. That's why we are talking about layers as the first thing that you can reduce this complexity. So present them in different approaches or in different purposes. So if you look at step number A, maybe you have activity A, and maybe this one you are talking about house. We are talking about foundation. So we talk about foundation. Maybe when you talk about B, we are talking about maybe cementing. Maybe you are talking about cementing. Maybe if you talk about the next one, we are looking at now maybe roofing. And maybe if you look at the next one, we look at now finishing. So those are now the process. So you have process one, foundation. The second process is cementing. The third one is roofing. And the next one is finishing the house. So for this case, we can say we are layering them. So we have the first layer. So this becomes the first layer. This becomes the second layer. And this becomes the third layer. So I have not followed the way the house is supposed to be built, but now you can understand the steps. Then this one, you can understand it as the fourth layer, where this is the third layer. So that's why we are saying we present abstraction, we hide whatever it's not required, and we provide layering so that we can be able to reduce this kind of abstraction, this kind of bottleneck that we have within the system. So if I can read this, and I hope you can see the notes. The message communication approach of object orientation facility, the creation of service layer within a design. So I remember when we talked about what you call a blueprint. We talked about what you call a blueprint. And a blueprint in modeling or a blueprint in system creation, it assists the user to understand the final systems. So it's like I'm presenting something that the way the system will look at the end. So if somebody comes and tells you now, hey, this is a good building, so I require that building to be the same. So you present a design or that. And that's why we are saying we allow a logical separation between different types of functionality, of which we have already separated them. Foundation, we cannot cement when you are creating foundation. We cannot roof when you are doing foundation. So one step must follow, or one step must start, then the other one has to follow. So in that case, we can say the system is able to communicate in a manner the user will be able to understand the system clearly. Like now, those projects that you'll be doing, I require you to come up with layering. And when you talk about the first project, maybe I'm looking at school management system. If I'm talking about school management system, maybe school management system, let me use a PowerPoint. So if I'm talking about our library management system, LMS, One thing that you require from this LMS is registration. The second one that you require is update. So you must update whoever is coming within that library. Maybe we need to look at disbursement. You disperse the books or lending books. Maybe you look at borrow and we still look at lending books. All these are processes that you require within a system. But one has to follow. One has to start, then the next one has to follow. So in this case, we can say the system has already been laid on, and that's why we need to present this term that we are saying here. So you need to present the first GUI. GUI means graphical user interface. Graphical user interface. So you provide the graphical user interface for this registration, provide graphical interface for this update, you provide graphical interface for borrowing, because you require some entry of borrowing, for lending, etc. That's why when you present your project, you present a system as LMS, but it has other subsystems. So these are the other subsystems. So the whole of this, we can say it's a model. The whole of that is a model. So in this case, we are not remitting. Remember, we are doing IT, and we cannot say that we are coming up with super highway. That's not a model in our course. So we need to come up with a structure that assists the users maybe to solve some issues. One issue is maybe security. The next one is role-based. Maybe the next one is maybe data recovery for that. Maybe you're using the interpretation of maybe you want to recover data, but this data, you need to save it somewhere. So you require a database. So in this case, each and every time that you develop a system, you require layers. You require a layer for a database. You require a layer for those interfaces that you have already talked about. And those systems will always resort to complexity. So we can say when we are using layering and when you are using abstraction, it allows portability. And I think portability is not new to you. What is portability? Maybe somebody can answer that. What is portability when you say we are having a portable system? What is the meaning of that? Maybe somebody can answer that, please. Richard, can you answer that? Don't escape my class, eh? Okay. Jerry, can you answer that, please? Or what is portability?
Okay, something which can be carried.
Okay, it is not clearly mentioned on that. But when you talk about portability, we are saying that it's carried, yes. But we are saying this is a model that can be used in various platforms. So meaning, if you use it in platform A, we can still use it in platform B, we can use it in platform C. Like now, if you look at most of the systems that we are using nowadays, maybe the one that we are using currently, that is the e-learning platform. It doesn't maybe restrict you to use a mobile phone. Serious. It doesn't even restrict you to use a computer. It doesn't restrict you to use a tablet or any other device that you can use. So portability means you can be able to move from one system to another, or it can be used by different softwares. So in this case, when you talk about system, you are using with Linux maybe. For me, I'm using with Windows. Maybe I'm using with Windows 2010. You're using with Windows 08. There is another one who is using it with Kali Linux. There is another one who is using with Red Hat. That means it is portability. So I think it is clear now. Is it clear? So that's why I'm saying if you are presenting your system, the moment you'll be creating your project, I require that project to be portable. And that's why we are saying we are presenting a model that is presentable in many other fields or in many other locations. So if you look at that, for our case, because we are talking about a model, now we can say our model is the project that we'll be doing. Up to now, you will have maybe a project title. So that project title becomes your model. So you must follow a systematic way of doing it. That's why maybe your supervisor starts with you from the first up to the end. I cannot tell you maybe to create a system right now. I want you, first of all, to define the objectives. Then I want to ask you, why do you need to come up with this system? Because there are problems. Which are those problems? Then after that, maybe how will you solve those problems? Then when you solve those problems, how will you present them when you are solving them? Why are we saying that this system is better than the other one? So now you become a software engineer. So when you become a software engineer, meaning that you can carry out the modeling in an ad hoc manner. So when you talk about in an ad hoc, we are saying in a simple manner as they are building the system. So just take away the system will be understood by the users. So in this case, we can say in our field now, as a software engineer or as a developer or as a programmer, what are the principles that I am supposed to follow when I'm coming up with this system? Remember, when you're coming up with this model or the system that you're having, we need to understand it. I cannot wake up and say, I'm coming up with a system for lending money. Maybe. I cannot say I'm having a project on lending money. But if you look at lending money, there are many platforms. You have mobile platforms, you have banks, we have other platforms that we have. Now, let me try to solve an issue here. Maybe I'm using lending money, but I can use a slight difference on the capability, the functionality. And most of these functionality that I can talk about is maybe I will use a less interest. Maybe I will provide a more duration to pay. That is solving the problem that is there. Nowadays, we have some issues on this COVID-19. How will you solve as a project? That can be a project where we can say maybe people are not well up with the information. So you can be able to come up with that project and you be able to assist the users. So if you come up with that model, you need to look at the choice. Don't wake up and say, I want to come up with the library management system. We have many types of library management systems. But what will you solve? That's why we are saying the choice of what model to create as a provide influence on how problem is attacked and how the solution is shaped. So understand the system. I want to come up with a system because I want to solve some issues in the area of my duty. Maybe I'm looking at COVID-19 where people are not even able to look for food. They have been locked up. Now, how can I come up with this project? Maybe I want to come up with a mobile application where I can be sending, maybe using a robot. Maybe I need to come up with a robotic way of doing that. Maybe I want to present it, maybe where I can maybe present using different views. So first of all, when you are coming up with any project or any other model, you must follow this principle. One, choice of what models do you want to create. Now, then you need to look at the model as a single entity. Don't look at a model where I'm looking at now COVID-19, then I look at maybe education. If I'm looking at how I can assist people on issues of COVID-19, now let me look at issues on COVID-19 on food alone. Don't go to maybe education. If I'm looking on education, leave alone food. So that is now why we are saying no single model is sufficient, but this model should be treated as an identity. So in this case, we say every non-trivial system is the best approach. That's why up to now, you will come up with a system that is in the market and I will still accept it. You will come up with a certain model that can be used to assist the user to do something, but I'll still accept it. Right now, I want to take you back maybe to the system that are done by users in the market nowadays. If I look at some issues, maybe I'm looking at the library as a project. When I look at a library as a project, I can create a model for that. Maybe I use a model using a neural network. So I need to use some data that is in the database. Then I come up with a structure for that. So I say, if this is the model, let me use paint. Sorry for that. So I can use paint. So if now we are looking at now a library management system, we always say we are using a DBMS or we are using a database. And when you are using a database, I can collect data from the database. When I collect data, then I come up with a structure of leading books. And this one will assist the campus to run its data every day. Meaning, if I look at leading books, how many users are borrowing books within the institution? Maybe 1, 2, 3. So you find that now you have ICT, maybe you have business, maybe you have another one for accounting. So for this case, when you're using an ICT, how many students have borrowed books from January to December? Maybe you look at the 1st January, maybe 4. Maybe if you look at business, you have 10. Maybe for the accounting, you have 0. This maybe for February, if you look at that, maybe here you have 2. Here we have 6. Now, if I'm a good provider for the information, I will now direct the campus, please, can you first of all buy books for business? Because business students are the ones who are borrowing books frequently. So I create a model that will assist the user to manage borrowing of these books. So instead of buying ICT books, whereas these ICT students are not even borrowing books. These accounting, even they don't know whether there is a library. So I will be able to direct the school, please, I have presented the thread like that. Maybe I have presented the thread for business is like this, for ICT is like this, for accounting, it is stagnant. So when I present this graph will assist the user to buy these books. So which are these books? Maybe the first book is maybe economics. So this is borrowed how many times? 20 times in that, or 10 times. So in this case, it assists the user. So if you can understand that scenario, that's why we are saying a model will never be certified. You never create a model and we say we have added the model. That's why you find we are still providing other means of Am I clear now? So can you hear me now? Okay. So the question that I'm asking is, are you able now to understand what is a model? Are we able now to define what is a model? And what I have said is that it's not a must you look at a model as a presentation of maybe something that you can see, maybe like Vika Superhighway. You understand a model as a project that you do today, today activity. Maybe I'm trying to come up with a project, but this project requires some processes to be done. And that's why I was saying, maybe if I can go back, and I was using Paint. If I use a library management system, I know that LMS is a data, it uses database. And because it is using database, I can develop a model for the institution so that the institution can be assisted on how many people are borrowing books in that library. So if I can look at the first, second, and then where we have ICT as a department, we have business as a department, and then maybe we have hospitality. So if I look at these three departments and we say we are borrowing books from January, February, up to December. So how many students have borrowed books in January? Maybe we say these are 2 in ICT. These are 10 in business, maybe 2 in hospitality. If I look at in February, 1 has borrowed, this has borrowed 20 students. This one has borrowed, 9 of them has borrowed. Now, you have to look at now, why are we saying that these students, most of the students that are borrowing books are from business? So in this case, that's why you can design a model by looking at these principles that I have talked about here. 1, why do we need to come up with a model? So you need to look at the choice of this model. Then the next one that I have said, before I come to this, I have said a model will never be sufficient. You never create a model and you say, okay, I have exhausted everything, nobody else who can come up with another model. No. That's why I was even giving an example. Whoever came up with the superhighway, automatically nowadays you are finding that now most of the people are now expanding the Vika superhighway. So if now this person came up with this project that you cannot expand again, it becomes a project which is not clear or clearly noted or identified. That's why if you look at my case scenario here, I can allow the user or I can allow the managers of this institution to buy books that are relevant to the library. I cannot advise these people to go to buy books from ICT for ICT and hospitality. These people are not borrowing books. I would prefer these people to buy books for business, more books for business, less books for ICT and hospitality. So in this case, what you are reducing, there are factors that you are reducing. 1 is the cost. Then we are trying to provide what you call efficiency. And the moment you are trying to provide efficiency, you now come up with an efficient model. You need now come up with a very clear model that is now trying to create some presentation that the users will be able to understand as a given in a given area of a field. So that's why we are saying this model that we are creating will never be clearly identified. You still come up with other presentation of that model. That's why we are saying every non-trivial system is the best approach. Through a small set of near-independent models, several different near-independent models are created to describe one particular system. But it should be possible to study these models independently of each other. So that's why we can be able to say that the first structure is not clearly noted or notified. Now we need to add other features within that. The same case to your project that you'll be doing. If you create that project, it has already been created by somebody. Even if you are coming up with a new project, you can add some features within that. That's why you find that you are coming up with a project that has already been done, but you can pinpoint one of the areas that has not been looked at. So you improve on that. The next one, the main principle that you can be able to look at now when you're coming up with these models is every model may be expressed at different level of precisions. Don't present them in the same level. So when I'm presenting the first one, I can maybe present the first one as what? Maybe registration. The next one is update. The next one as borrowing. The next one as lending. So treat these as independent models. And when you treat them as independent model, you'll be able to create them in a manner that the users will still be able to understand your model that you have created. The best models are connected to reality. This is the key point, are connected to reality. If you can look at the system that I was trying to create here, a model, it will advise the managers that you should not borrow books, or you should not buy books for ICT students. You should not buy books for hospitality students. Why? Because they are not borrowing books. So this is reality, real. That's why I was still saying that when you are presenting your model, present the model or the choice of your model. And in our case, let us not look at the business models. Let us now try to look at the ICT model. And the ICT model that I have already created is a library management system that will advise the users or will advise the managers on which books are borrowed frequently in the library and which books are supposed to be bought in the library. Look another case scenario, because we'll be using some case scenarios. Look another case scenario. If you are one of the software engineer, how can you advise ZTech University right now? Remember now we are doing e-learning. We will be doing exam using e-learning still, which is supposed to start from next month. So in that, how will you advise the student? How will you advise the institution? So I would advise the institution to implement a system that is efficient when the student is doing the exam. But how will you do that? You need to come up with a model. What is efficient? I cannot see efficiency. But through a model, I can be able to present efficiency. Because when I say we need to have a system that will always use very small bandwidth in connection, or will always be connected even if it is offline, maybe if I can advise that. But how will you do that? This is efficiency. Because maybe somebody is doing an exam and the system has already terminated the execution. So you are aborting the system. So in this case, that's why we are saying most systems must be real when you are presenting them. And that's why we are presenting a real system in that. So if you look at all these principles that you have looked at here, that's why we need to understand this, what we are calling UML, Unified Modeling Language. That is one of the language that you can use to define a model. So I can use that language to define a model. And before I go to Unified Modeling Language, maybe you can ask a question, because that is the next topic that I want us maybe to look at. And why do we need to have Unified Modeling Language? What are the purpose of coming up with this Unified Modeling Language? Which are these diagrams that you can use in Unified Modeling Language? Which are these software that you can use to come up with Unified Modeling languages that we have? So I would reach at that point. First of all, I received some questions, and maybe we can continue after that. So please, can you ask questions before we continue? So I'm waiting for those questions. So can I start with the first one? Maybe in my list, I can start with the first one, Evans. So please, you can use your mic to communicate. You can write an SMS. Maybe if you're using a video, if you have a video, you can raise up your hand. It is still advisable. I would even suggest maybe you raise up your hand if you're using a video. Is there any question? I'm waiting for those questions on the principles that we have discussed. have any question? Narasha, do you have any question? Narasha, do you have any question? I'm waiting for a question. You can either use an SMS, you can type that. Can you hear me? Team, can you hear me? Okay, is there any question? Okay, I have two answers. Any question after that point? Feel free to ask any question. You can use your mic maybe to ask your question. You can use an SMS. You can raise up your hand. Still around? Yes, Narasha?
No question.
Okay. So it is clear. So can we go to Unified Modeling Language? I don't want to block anybody for that before we continue. I want to allow everybody to be in the same class. Okay, allow me to go to UML diagrams. And the moment you're talking about the UML diagrams, so you're talking about Unified Modeling Language. And allow me to use Paint still. If you look at Unified Modeling Language, Unified Modeling Language, we are referring to a language that assists the user to come up with a finite model, or to come up with a good model that present reality. So in this case, a unified modeling language was created to assist the user to describe how the system are supposed to work, or how systems are supposed to do their activity. If you look at maybe the model that you want to create, how will it do that activity? How will you be able to clearly define the activities that has already been presented? So this language was using what you call syntax, was using semantics and notations. And when you talk about syntax are rules. That's why I'm saying I cannot develop a system for a hospital, then automatically I take it to an education field. So it must follow a certain rule. Then it must use what you call semantic. And semantic, we are saying these are meaning. Okay, I was saying there is a library management system, or I was saying there is a hospital management system that controls accounting, that controls how the system are supposed to do some work. Is it doing that? So if it is doing that, I'm following what you call semantic. Then you must use what you call symbols. Another name for symbols we will be referring to as is what you call notation. So we will be using what you call notations. And when you talk about notation, there are various notations, or there are various symbols that you can use in different systems that you create. And those are the ones that you'll be looking at after now we understand the functions of UML. Because we need to understand, why do we need to use this UML? So one, UML mostly allows the system to interlink together. It allows the system to communicate with another system. I'm looking at this system, maybe I'm looking at ZTech Universe system. And I want to come up with a model that will allow ZTech Universe system to interlink with the banks, maybe ABSA or maybe Equity Bank. When I pay fees using ABSA or Equity Bank, automatically it reflects in my portal. So how will I advise these people to create that system. So I need to come up with a model. So it assists the users to allow the user to interlink different systems together. It still allows the user to use different languages. So you can use different languages. And most of these languages we will be able to look at. Maybe we can use Terra, maybe we can use Visio, maybe we can use other softwares that are in the market today. And that's why we are saying the model is one where vocabulary and rules focus on conceptual and physical representation of the system, meaning it allows you to come up with a blueprint. And this blueprint is the one that we are interlinking. So we are saying, maybe I have system A, maybe I have system A, and I have another system B, I have system C. How will I create a model that can interlink to this system? Remember, these are different systems. Maybe this is a ZTech. Maybe this is a bank. Maybe there is a hospital. Suppose suppose a student falls sick. Is it a must now you carry everything from ZTech University? No, you go to the hospital, automatically present your ID, automatically to reflect to the system, and it is approved. You go to a bank in that. So we are saying we have some linking, and the whole of this, and the whole of this, and the whole of this is the one that we are calling what you call a blueprint, where still this blueprint will allow us to visualize. It will allow us to visualize. So if I can say, one advantage of a unified modeling language is to allow visualization, to allow presentation of, to allow visualization, to allow presentation of a blueprint, and to always make sure that now systems are able to communicate with each other, and still to allow developers to build systems that are able to communicate without failure. So you can reuse them. You can reuse them in the future. That's why we are saying, and everyone who build the system without writing down the model would mean all the ideas and efforts that system cannot be used in the future. So you need to write the model. Even if I die today, you can still use it. That's why if you look at the project that you do, we need documentation. Because if somebody comes and says, this system was not done the way it was supposed to be done, so let us now present this system in another way. So you need to present that. So unified modeling language assists the user to come up with a system that can be reused. Assist the user that can be that can allow the user to come up with a blueprint. Assist the user that can allow construction of other systems in the system that you have already provided. So in a summary, we can say unified modeling language is a language that assists the user to come up with a conceptualized system, logical conceptual and physical conceptual of the system. Allow the user to interlink different systems together. Allow the users to come up with a blueprint. But now the question is, the moment you are coming up with a system, which are the elements that you require in order to come up with this clear this system? So that's why we say they are building blocks of UML. And the building blocks of UML, they assist us to come up with a conceptual model. Right now, if I come here and I say I have a system like library management system, here I have registration, here I have accounting of, maybe I have lending of books. So the whole of this is a conceptual. The whole of this is a conceptual, which in a simple case, we are saying we are presenting what you call a blueprint. So there's a conceptualized blueprint, and another conceptualized blueprint. So these ones can communicate together. I can see whatever is working on the system. So in this case, that's why we need to use these building blocks. And these building blocks, one of them is what you call a thing. We call a thing, or what you call things. The next one is what you call relationship. And the third one is what you call a diagram. So when you understand things and you understand relationships, we will be able now to work with diagrams, where we understand that things are presentations of objects in different ways, or abstractions. So these are the abstractions that are the main element of the model. Which are these main elements of the model? If I say that I have a library management system, which are the main element of this model? The main element of this model is the structure. The main element is the structure. The next main element of this is the behavior, what it can do. And the main element is what you call annotation. So when I'm presenting registration, you require some annotation for it. You require structure for this. You require behavior, the aspect of doing something. So that's why we say a thing being an abstraction or a presentation of how the system is, it is always composed of 4 types. And these 4 types, one of them we have talked about structural thing, behavioral thing, of which we will be able to look at it here, behavioral thing, graphical things, and annotational thing. Those are the main things that you have that abstract the system. And those things that we have, we must understand which are these structural things we have. And one of the structural things that we have is the class. What makes a structural thing? When I'm building a house, what makes a house? Timber, stones, roofs, and many other things that we have. So this is made up of a class and a description of objects. Maybe in how the objects are able to communicate together. So you present a class. Maybe you can present an interface. Remember here I have presented an interface for registration, for accounting, maybe for reading, etc. Then after that, you need to look at collaboration. I have looked at that. This one is collaborating with this. In a simple case, we say they are doing what you call association. So if they are doing association, they can be able to communicate. Maybe you can use a use case. Use case, mostly we are looking at the actions and activities that are supposed to be done by this being. If it is a house, you need to sleep there. Maybe if it is a Vika superhighway as a model that you have already presented as a structure, you need to use it maybe for commercial purposes. And many others that you look at. So if you look at this structural thing, are the ones that will be able to assist us to come up with various behaviors. And the behaviors, and mostly, I can relate it to interaction or the actions that are supposed to be done by this structure. What can we do with this system? One, we can do what you call interaction. We can interact. We can have a state machine. A state machine is an interaction of an object, or what makes this interaction to be acted upon. If you're using maybe Vika superhighway as a model, now what makes this superhighway to be used as a commercial road for services? Maybe we need to use maybe a tar. We are using tar. We mix with the other component. Maybe we mix with the sand. We mix with any other. So you need to look at those aspects. So behavioral thing, we look at interactions. How the objects are able to communicate with each other, be able to accomplish a certain functions. But now a state machine is now how will you specify this sequence that we have. Like now, if you look at registration to lending, how is it relating with this? So the state machine will assist me to interrelate on how this one can work with this. But interaction is when this one is communicating this. But now the state machine is the one that is assisting me to do what you call interaction. So that is behavior. If you say, or you come up with a system and we say, I want to come up with a system that is able now to do what you call maybe security. So we need now to provide a mechanism on how we can be able to provide the security to be looked at in a manner that the users will be able to understand it clearly. So in this case, let us understand maybe library management system. We are looking at registration. We are looking at trading. How is it interrelating that? Whatever is now allowing us to interrelate with it is now what you call the state machine. So in this case, we can say, we can now look at the next one, grouping of things. Grouping, we need to use packages or package diagram to group them or to bring them together. Remember that when you talk about registration, registration has its own function. This one has its own function. This one has its own function. But suppose you say registration has to work together with the lending. You group this as one. So the moment you group A, either class, then you have here C and D are able to work together. So the whole of this, you use what you call a package. So this is a package. So how will you relate that? So you'll be looking at how we can present a package using a diagram. What are the main notations that we are supposed to use in order to provide this communication? So in this case, we say grouping is organizing element into groups. But we organize this element in groups by the use of a package. So we can use package diagram. So in this case, I can say I use what you call package diagrams. And I think you are asking what is conceptual. And I know you have done a 3-tier database architecture. Have you done a 3-tier database architecture? In the last class, that was January, April, did you do a 3-tier architecture of a database? Please, can you answer that? Tell me whether you have done that. Say yes or no. Did you do?
No.
No. Okay, if you look at a 3-tier, maybe if I go to database, which I'm not teaching database, but we are having some interrelation, we always have what you call the external. Then here we have the conceptual. There is not a clear diagram. Remember, I have some issues with the paint that I'm using. Then we can have what you call internal. So external, these are users. These are users. But when you look at the conceptual, we are looking at logical. So we are looking at how data is supposed to flow from one point to another. How data is supposed to be transmitted from one point to another. When you look at internal, here we are looking at the database. So in this case, which database are we using for you to do that? When you use that, they must be able to interrelate together. So when I talk about conceptual as a model, I'm talking about the flow of data or the flow of maybe some activities that you have. So you present those conceptuals. Package are conceptuals. So these packages that we have here, that we have said we have the first package and we have the second package, these two becomes conceptual. How data is supposed to be organized here. You organize data 1, 2, data 3, 4, etc. So becomes conceptual. The next one is annotation. And there is a point where we say the annotations are symbols. Which are these symbols that you're supposed to use? Remember, you'll be using different annotations that will assist us to come up with different diagrams that we have or that we'll be looking at in this. So if you look at that, we have already exhausted when you're talking about a thing, and please don't cram this, where we have said UML is composed of 3. 1, we have things, relationships, and diagrams. Things, we have structural behavior, grouping, and annotations. And when you talk about relations, I think this one is not new because in your database, you have already talked about relations. And the moment you talk about relations, we can say we are having relationships like, maybe one-to-one, maybe one-to-one relationships. Maybe we have many two-to-one. Maybe we can have one-to-many, etc. But in this case, we will be looking at how will object A, maybe we are having A, and then we are having B here. How will this object relate with this object? So in a simple case, we are talking about interactions. We are still talking about intersections of this object and cooperation of these objects that we have here. So that's why we are saying, if these things can be able to communicate together, you can rate that you need to have some relationships in that. And this relationship, we will be looking at relationship as associations, maybe dependency. How are they depending on the other? So for now, I will not be able to look at these diagrams for today, but if I can explain these, we can say class A and class B. Which class is depending from the other? So if class B is depending from A, now we say this is dependent relationship. Sorry. So in this case, we always represent with a dotted line. We represent that with a dotted line. We say B is depending on A. So the arrow points to B, to who is depending on the other. Right now, if you look at a parent and a child, who is depending on the other? So a child is depending on a parent. So you need to present that with a dotted line, and you say this is now depending on this. So there is dependency. So one class cannot live without the other. So one class must be there so that the other one can be there. The next one is association. So the moment you use association, we use a straight line. So we use a straight line like this. This is dependency. This is association. So these ones are associated with the other. So there are some characteristics that are here, and still there are characteristics that are on the other. If you look at a parent, there are those characteristics that you find on a child. If a parent is a thief, automatically maybe a child will always be a thief. You cannot miss one child who is a thief, if I can use that example. So those are the characteristics that are dependent on the other. So if you have a model A and you have a model B, so model A and model B are having some association. So we cannot present that. We present with a single line, with a single arrow, with a single arrow, not a double arrow, not a double-ended arrow. It is a single-ended arrow, meaning one object is having some relation of another. One is having some relation of another, and they are associating. But here we are saying one has to depend from the other. If one dies, no model which can be created. But for this one, if one dies, still the other model can still try to do some functions, because now it has its characteristics. Generalization, and I remember I explained generalization and realization. Realization is, with another case, we say it's specialization. Specialization. Meaning, we say moving from top to bottom and top to bottom, from top to bottom, we are generalizing, specializing from bottom to top. Meaning, if we have object A, and then we have B, then we have C here, and these are relating on this. So for this one, generalize, specialize, sorry. For this one, generalize in that case. So I think that is not new. So you always present with a continuous line, but with an arrow at the end, with an arrow at the end. So in this case, we can now try to create some relationships in that. We can try to create some relationships, and these are now trying to communicate together. Like now, if you are using a programming language, For association or relation, we say class A extends B, class C extends C. So class A extends, so we can say maybe class X extends D or F. So if we are looking at this, the characteristics that you find on class X are the same characteristics that are in F. So in this case, we can now associate them together. We are associating if it is programming. The last point of UML is what you call diagrams. The last one is what you call diagrams. And I think it is not new to you, because when you talk about diagram, we are talking about graphical representation. And there is where now we need to take time, because all these are diagrams that you look at, and I expect you to use them in your project. The moment you'll be looking at your project, you must include them in design view. Remember, if you look at a project, because you have done system analysis and design, we look at analysis and design. When you go to design, you always look at logical and physical design. In logical is the flow. That is when you present using what? The presentation of flowcharts. Maybe you can use context diagram. If it is a system analysis and design, maybe use level 1, you use level 2, you use level 0, which is called a context diagram. So in that case, we can say we are using diagrams as a presentation. But in object-oriented analysis and design, there are different diagrams that you can use. One of them is object diagrams. Maybe you present a student, that is an object. Class diagrams, we still repeat that. Use case diagrams. Then the next one is interaction diagrams, state chart diagrams, activity diagrams, component diagrams, deployment diagrams. Those 8 diagrams that we have here, because in interaction we can have sequence and collaboration. So we will tackle each and every one at a time. And it has its own notations. So please allow me not to continue with these system architectures. We continue in the next lesson that we'll meet. For now, I want us, first of all, maybe you can ask questions. These are the diagrams that you'll be looking at, and I expect you to use them in your project. The moment you'll be doing your project, I expect at least 5 or at least 3. Maybe you can use at least 3 diagrams. I can still add another one here, which is not there, which we are calling a package diagram, which is not there. So up to that point, do we have any question? Up to that point, do we have any question, so that next time we can start with those diagrams? Do you have any question? Please, you can talk. You can maybe use an SMS. You can raise up your hand. If you're using a video, please raise up your hand. I'm waiting for questions. I'm waiting for questions, my friends. I'm waiting for questions. Yes, Magara? Kefa?
Yes, Malima, I have a question concerning those diagrams and in designing a system.
Okay.
Maybe can someone use maybe the data flow diagrams?
Yes, you can use the data flow.
Are they part of the?
Okay. Okay. If you look at these diagrams that we have here, we can use still data flow diagrams. We can use still flow charts. Remember, I have not indicated them here because I know you have done this in system analysis design. You did them in system analysis. You did them in system analysis and design?
Yes.
Yes, that's why I have not indicated it here. But the moment you talk about UML diagrams, still DFD, you can use DFDs. You can still use flowchart. Maybe you can still use what you call decision tree, and decision table. But now you need to ask yourself, when are you supposed to use decision table and when are you supposed to use decision tree? So in this case, these are minor because I know these ones you do them in project, like now in programming. The moment you are doing structured programming, you did flowchart and decision tree and decision table. See, that's why I'm ignoring this. You can use them, but I'm ignoring them. Is that clear?
Yeah.
Kefa?
Yes.
Okay.
Yeah.
Yes. So the moment you'll be doing your project, don't hesitate to use any. You can use data flow diagrams. You can still use flowchart diagrams, but I would suggest for now, because you'll be able to understand these diagrams that you'll be looking at here, I would suggest you use those diagrams, because for each and every diagram that we have here, it has its own purpose. When you're using a use case diagrams, there is when you're using some interrelation of other objects. Now, when are we supposed to use? So you find that it is easier for me to understand when I'm using use case. So user can understand more when using use case, because if you use a DFD and I'm using a context diagram, that is level 0. My friend, that becomes hard for me to understand, because you do some abstraction of some data. When I'm using a use case, it becomes easy. When I'm using a component diagram, remember when I'm using a component diagram, it is like when you're using a flowchart. Or when you're using activity diagram, it is still like using a what? A flowchart. So we'll explain why we need to use this diagram. And one way that you can say is that they allow visualization. So it is good to visualize. It is good to create a blueprint as you look at the advantages of UML diagrams or UMLs. Am I clear, Kevin?
Yes.
Okay. Is there any question? If you have a question, you can ask. I'm not limiting questions. Anybody with a question? Please, if you have a question, don't let it go. Ask. Don't let it go. Please, you can ask. I'm ready to answer. Can we proceed? So we can interact here. Maybe we can say, can we proceed? Can I proceed? Maybe you can raise up your hand. I can see you. So Narasha, Evans, Richard, please, I'm waiting for your response. Okay, I have gotten the first one for Narasha. Jerry? Okay, we can proceed. Okay, I have majority. So please, I don't want to extend from here. I don't want to extend from here. I want us to have another class on Tuesday next week. We start with some few diagrams here. We will be working with 2 or 3 diagrams and other case scenario. I will be coming up with other case scenario. I will teach you on how to interpret them and to come up with different presentation. But for now, there is something that I want to tell you. There is an assignment that I sent, and I have only gotten assignment from, if I can remember, from Jerry. And there is another one. I don't know whether it is Anthony somewhere, something like that. But I have only 2. Please make sure you send them. If there is an issue, please tell me to extend the time, because those are the marks that are recorded. For anything that we do, we record those marks. I know that for now we'll do a quiz after this for that topic that we have already covered today, and I will still record it. Please make sure you do that quiz and any other assignment. It is counted in your last exam that you'll do. Please do that. So from here, I want us to go and interact. We can interact with wikis and we can interact with charts. But for the first thing that I want us to do, I want us to do a quiz that I will post in that portal. Please do it so that we can proceed from there. So we still have 1 hour. We still have 1 hour. Please let us meet in the next class, in the next chat room, and in the next quiz that we'll be doing. So can I proceed? Can I proceed? Can we go and do our quiz now? Okay. Okay, thank you for listening.